problem is probably a little bit trickier than maybe you realize. Initially when I looked at this, I was kind of confused about what they were asking for. So it says if a rectangle measures 48 feet by 90 feet, what is the length in feet of the diagonal? So we are a rectangle, oops, bad rectangle, 48 by 90. They wanted to know the length in feet of the diagonal. The diagonal goes across. How do we find that? Pythagorean theorem. Because a rectangle, we know this is a right angle, so we know we will use Pythagorean theorem for that. And the x is going to be our hypotenuse. Really huge number. Take the square root of that. It actually ends up being a nice number, which is 102. So the diagonal, and it would be then feet. Then they want the area of a parallelogram in this next one. Now in this case, again, they don't give us all the information we need. So that's, we'll see 6.2, and there's a little line there that means feet, and then 28 feet. And we want to find parallelogram is base times height. Now if it's a parallelogram, I know the base is 28, but I don't know the height. So I need to find that. That's going to be here. There's a couple of different options for us. We could either use special right triangles or we can use trig. So this is a 45, 45, 90. Use that. Otherwise, you could use trigonometry. Do you guys prefer trig or 45, 45, 90s? What do you guys think? Trig, I would agree. Especially since it's already a decimal, so then I'd have a kind of a more complicated. So this is the opposite sides. Good review for us. This is the hypotenuse. So I do sine opposite over hypotenuse of 45 equals the opposite, which is x, over our hypotenuse, which is 6.2. 0.2. So in order to find out x, we're going to multiply by 6.2. I don't know why it doesn't like twos for whatever reason. So 6.2 times sine of 45, that's going to give us our height. And I find out it's like 4.4 here. Once I know that, I'm just doing base times height. So 4.4 times our 28. Now when I do this, you guys, I leave that decimal in my calculator. It's a little more accurate. And then I just hit times 28. And then I don't have to do as much rounding, or I can't make as many errors with my rounding. So 122.75 says tenths, so it would be 8. And then this one would be feet squared. And if you didn't know that little line meant feet, it's okay. It's a little shorthand way for feet there. All right. So we're going to learn a few new formulas today. Again, it's kind of nice. We don't have to worry about memorizing these formulas. You'll be able to put these on our note card. I'll get you guys your note cards on Monday or Tuesday. So we want to talk about circles today. We're going to talk about circumference versus area. So circumference is kind of like the perimeter of a circle. So in terms of our circle, the circumference is the distance around. The thing is, it's not a very easy thing to measure. measure the distance around, even if I gave you guys like a circle and told you to measure the distance around, that'd be really tough to do because your ruler doesn't really go around it very well. So you need some sort of string or something like that to help you with that. So it's the distance around is our circumference, so how far around. So if you picture a totally perfectly circular lake, it's how far around it would be. I have two formulas for circumference, and we're going to talk about a few things involving a circle. So it's C for circumference is 2 times pi times r, and pi is a button in your calculator. It's pi, which is 3.1492, whatever, you know, like that goes on forever, or pi times d. Now we've talked about d before in other sections, and that was the diagonal. Now d in this case is going to be diameter. So it might be worth writing this over here on the side, that when I'm talking about a circle, the radius is the center to the edge, is a radius, whereas diameter is all the way across through the middle. Now, an interesting thing to know about diameter and radius is that the diameter is 2 times a radius. So if I put 2 radii together, it's a diameter, straight across. If I go halfway and then halfway again, it's all the way across. So that's why the formula, you can use either one, because 2 times r is d, so either of these formulas work. Then the area is the distance as the amount inside. So like picture like, we've probably all seen those like above ground pools. A lot of times they're circular. If you're trying to figure out like the tarp to go over the top, or like the thing that makes it the heater, like, you know, the sun catcher heater thing. So it's covering the top is our area of our circle, so cover it. Area is pi times r squared. Now, order of operations is important, where you actually square r before we multiply it by pi. And in your calculator, you should use the pi button. You shouldn't use the decimal approximation 3.14. So use pi. It makes it a little more accurate. So it says find the circumference and the area of a circle, the diameter of 10 inches. So using these two formula, we're going to find the circumference and area. So I'm going to draw you guys kind of a quick picture with it, just so you can think about what we're talking about here. So all the way across is 10. That means it goes through the middle if it's diameter. They want the circumference and the area. Now they're giving me d is 10. So in that case, then, I'm going to use this formula, because it gives me what I need. So I'm going to use c equals pi times d. So not much work to do with this one. Now you're going to want to use, again, pi in your calculator. And let's go 2 decimal places. Ends up being 31.42. Now it's inches, so the distance around, just like perimeter, is just going to be inches. So, you know, if Zippy was crawling in a circle, he would have gone 31 inches. Now for area, we only have the one formula, pi r squared. How do I find r? Yep. Yeah, so we're just going to divide 10 by 2, the diameter divided by 2. So r is the diameter divided by 2. So 10 over 2, so r is 5. You don't even have to show that, but... So we know our r is 5. So when I go to put that in, it's pi times 5 squared. So I have to do 5 squared first though. So I'm not doing pi times 5 and then squaring that. I'm going to do 25 times pi. And we'll get our area of about 78.54, I believe. Now careful, on this one it's going to be inches squared because it's area. So it's the amount covered there. All right, this next one makes you think outside the box a little bit. So it gives us the circumference. We want to find the radius. So I'll give you guys a minute to look at this and see if you guys kind of try to figure out how to work your way with this one. So try number 2. Keep an eye on time then, and then again, it'll be online if you did. I'm glad I said something then. At first, like, I don't want to tell you to leave early, like, if that's wrong, but I also don't want you to be late for an appointment. All right, so they want us to find the radius of a circle with circumference of 65.4. Now, they give us the 2 formulas for circumference. Since they want the radius, in my opinion, it would make sense to do the one that involves the radius. So C equals 2 pi r. So since I'm trying to find r, I'm going to use that. They're giving us the circumference, so we put that in place of C, which is 65.4. I'm trying to find r, and this is being multiplied to r, so what can I do? Divide it by what? So we can divide by pi, we can divide by 2. You can do that at once as well. You just have to make sure you use parentheses if you do that. So you can divide by 2 pi to give this alone. So if you guys do this, you might have to put parentheses around 2 pi in your calculator. Otherwise, your calculator might try to just divide by 2 and then multiply by pi. So you might need the parentheses depending on what your calculator does in terms of order of operations. And so I got like 10.41. That sound right?
Yeah. It doesn't.
It does it okay for you?
It doesn't.
Okay. Yeah, I think yours, but any of the ones, that one works nicely that way. Just make sure you guys.
See on this one it goes.
See, now she has the same one, but you must have it in a different setting. Yeah, because hers, like, same calculator, but she
I
had
got
it.
102.
Isn't that crazy? So, it kind of just depends. So be careful about that. So use parentheses if you're unsure. Yours is pretty clear that it's in the right spot because it made it in. Did you do a fraction button?
Yeah.
Oh, so she made it in a fraction. That might help. Rather than using it. She used division and then it didn't work correctly. All right. Let's do a little bit more on the backside. We'll take a break then. I don't know if we can go outside. There's little kids running outside, which makes me think it's still raining.
It's still raining. Yeah, no. It's like raining right now.
Raining.
Yeah.
They're all running and screaming.
Yeah, I think it's about.
Yeah, isn't that, it
If
works.
you put it in
The fraction, it works nicely. Okay.
I'm
All right. So guys, formulas. Again, this would be great for your note card when you need to make that. So we're gonna start with the shape, or what we're asking for is the area of a circle. And we just wrote this formula down. Where this is r, it's given to us. And then I'm just going to remind you guys this is going to be units squared. Now the next one we're going to talk about is something we haven't ever talked about before. It's called a sector. But it's like, if we talk about it this way, it'll make sense to you. This is like a slice of pizza. Like, how big is that slice of pizza? And it's part of the whole circle, so we can't just, it's not just a triangle, it has that curve to it, so we have to add in a little bit of extra of a piece here, or a thing to be worried about. So, the area of a sector, which is, I'm going to call it a slice. And I might do a little example with this one, just so we can see it. So this formula is a lot more complicated because this is basically a fraction of the whole circle. And what this is right here, I don't know if you guys can see it clearly on your notes, but that's x degrees. So that's a degree. So they're gonna have to give you the degree value of how big of an angle that is. Now, what's all the way around a circle? How much is it? 360. So this is saying, what fraction out of 360 are we getting of this pizza slice? And then we take that fraction and we multiply it by the normal area. So I'll do a little example here with you guys on this. So let me give you, so again, the x is the angle at the center. So I'll show you guys an example of this. Just so we can kind of, because I feel like the ones down below are a little bit tougher. So if this is, do 60 degrees, and this is 9. So that angle is a 60-degree angle, and the radius is 9. Now I know you're all going to be measuring your pizzas tonight and the angle of the pizza slice, clearly. Just give me a second here as I measure my angle. But, I mean, so obviously there's other applications other than eating pizza. So we do 60 divided by 360 times our pi r squared, so pi times 9 squared. Now, again, depending on your calculator and how you put this in, just have to be careful with it. I actually work usually like this way, kind of strange. I usually do the 9 squared, multiply by pi, multiply by 60, and then divide everything by 360. So I kind of work this way. It kind of helps me so I'm not worried about having that pi 9 squared in the denominator. Oops. And I got 42.4. Sound right? Anyone else? That's why they moved the graduation indoors.
They did?
Yeah.
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 No, we're still going outside of that. Bring all the percussion and all the instruments.
It said like showers in the vicinity, but like that's rain. It's for real. That's not like showers like, hey, it's a little bit of rain. All right. Do you guys want to take a little break? Yeah. Go for a big walk outside.